Good evening, one and all. I guess we can wait for 2-3 minutes because everyone is joining. So we'll start in a few minutes. I guess we should start now. Let me share my screen. I hope it is visible and I'm audible to you.
Yeah, it's visible.
Okay. So, good evening, everyone. This is the 10th live session for the course Basic Environmental Engineering, Pollution and Abatement. So far we had discussed about the strategies, what are the basic air pollution, water pollution, solid sludge management, its pollution control strategies. And now we are looking into specific industries, what are the processes involved, from which process and from which unit, what type of waste is generated, and how do we treat? Because depending on the industry, there can be some changes in the process, and we, depending on the type of pollutants present, we obviously change the process that we can use, or we can have some uh, modification in that. So now, in this week, we had studied few industries, and starting with that, first one was the ethanol production. And ethanol, as you know, that it involves sugarcane or sugar-based products, and where you can have this reaction, which is sucrose gets converted to glucose and fructose in the presence of enzyme, and this is the most common or basic chemistry reaction. Okay, so now this glucose and fructose, they further get fermented in the presence of yeast to ethanol and carbon dioxide. Yeah, so this is the basic reaction that occurs in the production of ethanol in the reactor. Uh, but obviously, the industrial process is way more complex. And in India, it is observed that molasses is the major raw material that is used for the ethanol production. So starting with the sugar mill molasses that is obtained, now that is stored and further it is diluted so that we can process it. Now, as you know that the fermentation requires or it occurs in the presence of yeast. So yeast is cultured in a laboratory and now this molasses is fed with yeast where fermentation occurs. So this is the fermentation unit. Now fermentation results into the production of ethanol and obviously you need to separate some solids or unreacted product which is remaining. So this is clarified wash tank and you can even pass through decanter if there is some sort of because initially it was molasses, right? So there can be some sludge that needs to be separated, right? So that can be separated and further be used as manure because it is nothing but a bio or some sort of waste from sugarcane, right? So it is biodegradable and hence can be used for manure. Now here this will have water mainly plus ethanol, right? Because molasses was diluted and after the fermentation, you get ethanol. So water and ethanol will be the basic products from this, right? So you pass it through a distillation column. Okay, so mother liquor is separated and water and ethanol is passed through a distillation column here, which is known as rectification column, right? So ethanol, which is having lower boiling point, it will be obtained as the top product and water will be obtained as the bottom product. But purification of ethanol from water above 95% purity is usually not observed, like through this distillation column. So here you will have 95% pure ethanol. Ethanol. Okay, so here it is observed that after 95% purity is attained for ethanol, the boiling point of ethanol and water tends to be approaching to 1 point, which is normally the boiling point of ethanol is 77, whereas water is having boiling point of 100 degree. This is at atmospheric condition. So if the column distillation is operated at this atmospheric pressure, then these are the boiling points. Now, if you change the concentration of these two, then at particular concentration where ethanol is 95% and rest is 5% water, then the mixture has a common boiling point. So now since the boiling points are same, you will not be able to purify it further. So you can have another strategy to further purify, which can have. So this mixture is nothing but known as azeotrope, which is nothing but a constant boiling mixture, right? So now this cannot be separated using the conventional distillation process. So you can have molecular sieve, or you can have azeotropic distillation. Um, or some modification and distillation you can have and further you can separate it to pure alcohol, okay, which is nothing but absolute alcohol. So now during this process this spent wash which is formed, it contains water plus the sugar. Okay, so this is the main spent wash content. Now this is very dilute, so further to concentrate it you pass it through multiple effect evaporator and then the concentrate is again can be sent to boiler where bagasse from sugar industry can be fed as the fuel. Now the condensate which is obtained, it is further processed in this condensate processing unit. So majorly the sources of water, are this paint wash or any sort of cleaning which is done, or the condensate which is obtained. So for that, what usually is um, adopted is firstly you do evaporation to recover the water, and whatever the solid is obtained, you incinerate it, and potassium is recovered. And another is the biomethanation strategy, where first biomethanation occurs, and later you have aerobic treatment to deal with BOD, because since um, here you deal with sugar cane or molasses, which is a biodegradable solid. It will mainly constitute of some organics. So you can give aerobic treatment, which will easily degrade the contents, and later you can have some sort of tertiary treatment, and the sludge that is obtained you can further use it for uh, agriculture. And further, the water can be even used for irrigation, because it does not contain much harmful chemicals, right? So this is the general strategy for wastewater treatment. Now, sludge, as I mentioned, that it is not so toxic here. So sludge generation is usually, it can be sent to biodigestion, and it can be used for biocomposting. Another way is you can use it for boiler. Now, air pollution, major sources are evaporators, which are nothing but multiple effect evaporators, and the cogeneration or the power plants, right? Because you burn the fuel. So these are the main sources of air pollution, and usually, since these are very common, so common conventional air pollution control is adopted. Noise is usually generated through steam vent, steam licks, and power generators. So this was all about ethanol production. Now moving forward, another industry that was discussed was tannery industry. So tannery industry is nothing but production of leather, which uses skins and hides of animals. So how you do, uh, like as the name suggests, you utilize skins and hides of animals. So the animals can be um, it can vary, and obviously you recover the skins and hides of animals first. Now this skin and hide will have flesh also of the animal. It will have blood. It can have another impurities. So firstly, to remove all those impurities, you soak the skin and hide, or mainly hides. Say for example here. So firstly, you soak it to remove all the impurities which are in the form of any dirt, blood, then it can be some another impurities, right? So all those are removed by soaking it. Now, next step is remove the flash, because it will have flash. So remove the flash by adding lime and sodium sulfides. This will result into the removal of flash. And even after that process, if there is some remaining flash uh, on the skin, then it is removed manually, okay, which is known as flashing. Now, after that, there can be some excess of lime which was supplied during the process to remove the flash. So, next step here is to remove the excess lime by ammonium sulfate, or matlab, you neutralize the lime by ammonium sulfate and ammonium chloride. And next treatment that you give to this hides are nothing but batting, where you make it, try to make it soft. Now, tannery industry, or the name comes from chromium tanning of hides, where the skin gets transformed or converted to leather, right? So here uh, chromium based chemical is used, which results into transformation of this hide to leather. So this is the main or important process of this entire industry. Now after that, the you can do bleaching or you can give dyeing to the leather so that you whatever the color or some visual or aesthetically pleasing leather you want to manufacture, that can be done through dyeing. The next step comes is the fat liquoring process where you treat the leather with oil and water emulsion. Here, this process is done because leather can be brittle if it is used as it is. If produced so far is used as it is, then it can be brittle. So to improve its strength and improve its other another properties, what we do, we treat it with oil and emulsion, right? And finally, we provide the finishing to the leather. So here, mainly, this is the wastewater treatment strategy. So, one of the most important wastewater contaminant here, you can say, is um, obtained from this main process, which is tanning process. Now, since it uses chromium, so chromium can be a major component of the wastewater, and now it this chromium is a heavy metal which poses much toxicity. So it is not advisable to mix this chromium containing wastewater with the wastewater which is obtained from any other process of soaking, liming, and so on. Right, so majorly the wastewater which are obtained from another processes, it will have BOD, COD, suspended solids, and it will have total um, some dissolved solid TDS, etc. Right? So these are the basic components, but apart from that, there will be a huge contribution from chromium. So what we do, we try to reduce the hazard by separating or segregating the chromium containing stream. So this portion is for chromium recovery, and the another wastewater stream, non-chromium wastewater. These are collected separately. So, firstly, you pass it through equalization tank because you mix wastewater from different processes. It passes through primary clarifier, then it again goes to aeration tank, secondary clarifier, and the sludge is separated, which goes to sludge drying beds, and treated water is collected. Now, for chromium, as I said, this there is some different treatment technology. So, chromium bearing wastewater is collected or it is equalized, and here it is treated with MgO. Now, this MgO reacts with chromium to form precipitates of chromium, and this precipitate is again converted to some usable form of chromium sulfates, which is recovered to the main process, right? So this is all about chromium process, and the above the decanted water which is obtained after the precipitation of water chromium from the water, it is sent to the main wastewater or the ETP plant where actual the entire industry wastewater is treated. So, sludge obtained in the industry mainly uh, contains chromium. So, as we know that chromium is precipitated, so precipitates of chromium are obtained. And now, as this is chromium salt is very harmful, or it poses very much hazard. So it cannot be directly used for some biological treatment or agricultural use, which we often do for the ones which are easily degradable or less harmful. But so here we will just send it to landfill sites and properly cover it so that even further toxicity through leachate formation or so are not obtained. Right? So this was the major things of tannery industry. Moving forward, next was discussed is the petroleum refining process. So petroleum refining mainly deals with the production of petrol, diesel, and like there are n number of products. These are just the example, right? So as you know that these products are generated from crude oil, right? So crude oil is sent to the atmospheric distillation unit, which is known as ADU. Now this atmospheric distillation unit name comes from the pressure at which this distillation column is operated, which is 1 atmosphere. So that is why it comes out to be atmospheric distillation unit. So now this crude oil will have n number of components in it, right? So the distillation column operates on the principle that light boiling components are obtained at top and high boiling in bottom. Right, so this is the basic working principle of distillation or any distillation column. So since crude oil has n number of products, so you will not just have one single top product and one single bottom product. You will have various cuts. So for example, there will be petrol and diesel, so both will have different boiling points. So petrol, if it is light naphtha, you can say. So here you or you can say gasoline. So if this is the cut, this plate comes has the operates under the boiling point of petrol, then there will be provided a cut from which you can continuously draw light naphtha or gasoline. Right, so there will be similar cuts which will be provided near to the tray, and it depends on the boiling points of different cuts that you want, right? So these are the basic products. You can have gases which are very light boiling, and you can have methane, ethane, and some other organic compounds. Then after that, depend as the molecular mass increases, the boiling point will increase, and you will have gasoline, then heavy naphtha. Then you can have jet fuel and kerosene. Jet fuel is nothing but the fuel which you use for uh, uh, airplanes. Then you will have diesel. Then you can have petroleum products which are very high boiling. So further to separate them, we send it to vacuum distillation column, which operates at under vacuum. So you do not have to go much high temperature. So you get some products from here also. And further, this can also be cracked into FCC to further obtain gasoline, right? So this is fluidized bed catalytic cracker, where you convert the uh, oil which is obtained in the vacuum distillation column, which are very high, which are having very high molecular weight. So you do say for example, it is having much more or very long carbon chain, then you try to reduce that carbon chain and such that you get gasoline. So this catalyst which is used here in the FCC, that catalyst is such selective that it produces more and more petrol from that uh, cracking, right? So cracking nothing but means conversion of high molecular weight into small molecular weight compounds. So by which you can generate more fuel. So moving forward, you can say that the sources of wastewater in this plant usually have much more BOD and COD because it deals with organics. So it will have oily effluents, it will have spent caustic, then regeneration effluent and sanitary waste. So depending on different pollutants, there can be some specific treatment strategy, right? So for oil, for example, you can use dissolved air flotation, where oil being lighter, you can skim it off. Then suspended solid, it is very common, like you can have settlers, right? And sulfide is the major pollutant which is very common in such industry because crude oil will have sulfur, right? So sulfur content needs to be optimized for the final product also. So sulfur or sulfides containing wastewater is very common from this industry. So for sulfides, you treat it with hydrogen peroxide, so it is converted to, I guess, H2S, which can be further recovered and treated. So now sludge management, coming to that, sludge management usually requires the sludge management obtained from thickeners and centrifuge. And since this is not biocompatible, so you usually send it to landfill sites. Now, as I mentioned, that sulfur is a major pollutant here. So, air pollution control strategy requires desulfurization of fuel gas. Otherwise, you can have SOx in air. Then, if some amount of SOx are released, then you can have sulfur recovery. And also, you can use tall stacks of exhaust so that nearby residential area or any people are not contaminated with that. So moving forward, there are n number of products which can be derived from the final products which were obtained by petroleum refining or the products obtained from crude oil. So these are the products which can be obtained. And similar to the previous one, you can have emission and effluent from the spillage and storage of the raw materials. Then there can be some waste streams generated from obviously the reactors, distillation columns, condensers, reformers, etc. And there can be some leakages from the pumps, valves, from the seals. So that needs to be taken care of, right? So this is all about the petrochemical production, where you usually product some important polymers or any chemicals, say for example PVC, then polythene, then it can be polypropylene, there can be any such sort of final product. Now moving forward, another industry that was discussed was pulp and paper industry. So you know that paper is the basic need in each and every sector, and it is usually synthesized from wood, right? So how wood is converted into paper? So for that, firstly, wood is debarked, which means that you remove the impurities in the bark. So first, you scrap the outer surface of the wood, which is known as bark. So you remove that, and after that you purify uh, that. Okay, and you cut it in small pieces so that it is easy to manage. Now, you need to generate the pulp which further produces paper. So there can be two type of pulping, which is known as mechanical pulping or chemical pulping, where chemical pulping is most common. So here you use chemicals which separates lignin, right? So, wood has three basic components. It is cellulose, it is hemicellulose, and last is lignin. So, lignin is the least reactive and difficult to remove component. So, chemical pulping tries to separate lignin from the wood. Okay. Then you apply bleaching because the pulp that is obtained, as you see here, it still contains lignin because it is difficult to remove. So it is lignin has brown color, right? Dark brown color. So pulp is of dark brown color. So if you apply bleach by adding various chemicals, it will remove some another impurities and it will remove the leftover lignin, right? And it will make it whiter. So now you wash this pulp and it is sent to paper making where you add some fillers and some dye if you need colored paper. So it is passed over um, a roll or a belt where dewatering of the pulp occurs so that the water is drained and somewhat dried pulp is obtained and then it passes through rollers where the pulp is converted into some sheet form. So this is and further you can have some sort of treatment coating for making it shiny or so on. So these are the finishing steps and finally you will have paper. So right, so this is very extensive in wastewater generation. This industry is very extensively generating high quantities of wastewater and it can have high quantity of lignin and another chemical which are used for removal of lignin and so on. So wastewater is further firstly given primary treatment which undergoes anaerobic digestion. So because like multiple stage of digestion is required here because the lignin content and the BOD and COD content are very high. So to enhance the efficiency for organic removal, we have multiple stages of digestion. So firstly anaerobic and later an aerobic treatment is provided. So here the sludge that is obtained that can be used for biogas or methane production and also some irrigation can be provided through the water which is obtained because wood is the primary raw material here, so it will not have toxic components here, much toxic components. And the sludge then can be finally incinerated if required, if the quantity is more. Next is urea production or which is a kind of fertilizer which takes care of the nitrogen requirement of the soil. So urea production occurs with the usage of ammonia, which reacts with carbon dioxide, and this is the by intermediate product which is formed and which further gives you urea. So this is urea, and this is the main reactor where reaction occurs. So here the main sources of wastewater it can be process condensate, scrubber waste, cooling tower blowdown. So if you look into the uh, uh, numerical values of this industry, then you can say that only 17 to 20% of highest conversion of ammonia is obtained to give urea, right? So conversion is very low, and you cannot waste the remaining ammonia which is obtained. So what you do, you try to make the process economical by recycling it. So major process or the unit in this industry is stripping of this ammonia and recovery or recycle of that ammonia. So which is done here. So which is scrubbing of ammonia. So the waste obtained from here, it is a major source of wastewater in this industry and it usually contains some organic compounds because here you are synthesizing urea. Then there will be some nitrates because ammonia is used, so nitrogen containing or nitrates can be obtained. Alcohols, then some sort of heavy metals are also obtained. Now, nitrogen, which you can say is the major pollutant here. So, that nitrogen can be removed from wastewater through some biological treatment like nitrification and denitrification, or you can have some sort of steam stripping by increasing the temperature so that nitrogen can be um, converted to gas, right? Or you can have ion exchange. Moving forward, next industry that comes is copper smelting. So this sort of industries are the smelting industry where you try to synthesize pure metal. So copper or iron or steel industry are the kind of industry like which come into these categories. So look, if we look into copper production, then first is how do you generate copper is there are some ores which contain specifically copper or which are rich in copper containing compounds. So for that you dig into that area and you extract that ore. Now, that will have much more impurities and the concentration of copper or the targeted element or say for example even iron, then that will be very less. So what you do, you concentrate that by flotation. Right, so flotation results into uh, copper product coming into the top, and that is recovered. Now that top product is sent to smelter or smelting unit, which is nothing but is a furnace operated at a very high temperature, maybe above 800, where the reaction occurs to form pure copper. Now that is electrostatically precipitated into various forms at anode and cathode. Right, so that is how you recover. So here, since ore is involved, so initially during the phases of crushing of ore and so on, there will be a lot of particulate matter and dust that will be formed, resulting into air pollution. Obviously, there will be some metal contents because copper is extracted from metal containing region, right? There will be SOx, NOx produced, right? And wastewater will have, since it is a metal industry, so it will have soluble, insoluble, various sorts of metal compounds. And also, obviously, there will be organics, and the wastewater will be acidic in nature. So, such wastewater needs to be taken care of. Now, if you don't have any doubt, then we can move forward with the assignment. Yeah, so let's move forward. In India, ethanol is mostly produced from dash. So, can anyone tell me?
Molasses.
Yeah, so molasses is the correct answer. And if you can recall, then molasses is the byproduct which is obtained from which industry? So, that is also a related question that you can answer.
Sugarcane factory.
Yeah, so molasses, which is the byproduct of sugarcane industry. So, you are here trying to use the waste product obtained from one industry into another industry. So you are trying to make the synthesis or the production sustainable, right? So you are generating less and less waste, or you are trying to utilize that, which makes it sustainable. Next is in sugar industry, multiple effect evaporator is mostly used to concentrate spent wash up to dash degree bricks. So it is usually 58 to 60 degree. So if you look into the definition of bricks, so it is the amount uh, or it is the measure, you can say not amount, measure of the sugar content in water or wash water, anything you can say. So initially it is very dilute, which was around 14% or so. And later you concentrate it to 58 to 60 degree so that you can have further usage of it. And you recover the evaporated water in further process you can say where you can heat another reagents where it is required, or you can use it in boiler and so on. So there can be multiple usage of the water which is recovered. Next is the percentage composition of potash in boiler ash in a distillery is around dash percentage. So you are asked about the percentage of potassium content in boiler ash, which is around 14 to 22%. So these are all the statistics which you need to look into the lectures. Okay. Now moving forward, the physical properties of the leather are highly improved by dash process.
Tanning.
No, tanning is not the correct answer. Tanning is the conversion of skin or hide to leather. So this is the actual reaction process. Fat liquoring is the correct answer, where you apply oil water emulsion, which goes into the pores and hence it improves its property, right? So fat liquoring is the correct answer by using oil water emulsion. Okay. Next question is in pulp and paper industry, dash process produces maximum pollution intensity in wastewater.
All the above.
No, you are asked maximum, so bleaching is the correct answer because bleaching is the one where you remove the lignin, which converts extremely dark brown pulp into white. So it has firstly, like why it generates such high quantity of wastewater because to reduce such high quantity of lignin and such products, or you can say lignin, color, or some impurities, multiple stages are required, right? It cannot be done in single stage. So multiple stages are required. And also you will not be able to, like usually what we do, we try to reuse the water uh, in the process. So that is nothing but very common in industry. But here in bleaching process, you are not able to, we cannot reuse or recycle the water. So we require fresh water in each and every stage, and it should not be contaminated. So that is why you can say, sorry, as compared to other processes, the quantity or the intensity of pollution in wastewater from bleaching process is much more higher as compared to other. Bleaching is the correct answer. Find out the most suitable option relating to the component present in the wastewaters generated from chemical fertilizer industry. So this I have mentioned earlier, which says that all of the above, like since it is a chemical fertilizer, so ammonia, which is the main raw material from for fertilizer industry, so that is product, and this are some of the byproducts, or there can be some contamination due to which alcohols and heavy metal like cadmium they are also obtained. So all of the above is the correct answer. Next is identify the suitable option from the following matching different wastewater streams of petroleum refinery and their important contaminants. So if you look into spent caustic, so petroleum refinery usually has sulfide contamination due to crude oil containing sulfur containing compounds, and it is usually high in BOD, COD, and it has oils. So for P, two option is the correct answer. And if you look into sanitary waste, then it will have BOD, and obviously that it will have total suspended solids, you can say. So some suspended solids. So one is the correct answer. So P2Q1A option is the correct answer here. Which of the following measures is not appropriate to control air pollution generated in petroleum refinery? So, petroleum refinery requires desulfurization of fuel gas because sulfur content is very high, or you can say it is a common problem which requires desulfurization. Installation of sulfur recovery unit is obviously required because of the sulfur content. So you try to recover it. Then use low NOx burners. This is a common strategy which is applicable for every case. And so these are all correct. Then small stacks for dispersion of exhaust gas is not suitable because, or this is wrong, because we require tall stacks so that we have the dispersion of air above which like so that people in the ground they are not affected due to it. So tall stacks are usually, so instead of tall stack small tall stacks are required. Next is the flow rate. This is a numerical. So flow rate of wastewater from a tannery industry is 4 kiloliters per day, and it is having a chromium content of 20 milligrams per liter. So if we note down the values, then flow rate of water is 4 kiloliters per day, which is 4,000 liter per day, right? Now the chromium content or the concentration in of chromium is 20 milligram per liter, which means that there is 20 milligram of chromium in 1 liter of wastewater. Now, as per the CPCB standards, the effluent should not contain the total chromium more than 3 milligram per liter. So, C out you are given to be as 3 milligrams per liter. Okay. Then, what is the rate of removal of chromium in gram per day required in ETP? So, actually, you need to just find out what is the amount of chromium removed. So, if we check the process, what is happening? So, Q in, and considering equilibrium process, Q in and Q out are same, obviously. And here C in is 20 mg per liter, and here C out is 3 milligram per liter. And here you remove chromium by precipitation, which is usually in gram per day. So, how do you do that? This is a basic mass balance question.
In is equals to out plus accumulation.
Yeah, so in equals to out plus Yeah, you can
Okay.
say these two are, this is one in, and yeah, obviously that statement is correct. So accumulation, here, whatever the concentration is inside, that will be coming out. So overall mass balance, you can say uh, in equals to out here because we are considering equilibrium process. So there is one in stream which is Q in, right? So here you apply mass balance. So mass of chromium coming in is mass can be obtained as flow rate. So flow rate into mass. Okay. The flow rate is in liter per day, right? And if you multiply it with concentration, so concentration is in milligram per liter. So right, what will remain? It will be milligrams per day, right? So C in. Now you do not want in milligram, you want the final answer in gram, right? So convert this milligram into gram by multiplying with a factor of 10 to the power minus 3, right? This is the conversion from milligram to gram. So 10 to the power minus 3. Okay, so now there are two outstream streams, which is Q out into C out, and obviously there will be a factor of 10 to the power minus 3. And here this is the chromium, which is chromium Cr out that you need. Okay, so Cr out is nothing but, so Q in is given to you as 4000. Um, Now Qn and Qr out same, so you can take this out common. C in minus C out into 10 to the power minus 3, right? So this will just left uh, remain. So Q is 4000 liters. C in is 20 milligram per liter minus C out is 3 milligram per liter into 10 to the power minus 3. So if you do that, calculate this, it should come out to be, I guess, yeah, 68 gram per day of chromium is removed. I hope you are able to get or understand the mass balance here. Are you getting?
Yeah.
Okay. So should we move forward? Okay, so let's move forward. Uh, okay, so there is one more numerical. So in an industrial biogas plant, food waste is anaerobically digested to produce biogas. The slurry contains 20% of solid food grains, and the elemental composition of food grains on dry basis is C is 50%, H is 10%, oxygen is 30%, nitrogen is 11% on mass percent basis, and around 80% of the food grains are converted to biogas, and all the converted hydrogen forms methane. If the flow rate of the slurry is 5000 liter per day, then calculate the amount of methane which is produced. Density of slurry is given to you as 1 kg per liter. So, um, this is also a kind of mass balance numerical, and we have solved many mass balance questions so far. So, I will now request you all to give me step-by-step hints so that we can solve. Like, obviously, I will solve, but you can tell me and initiate how to solve. So, firstly, for every question, you write down the data which is given to you in the question. So, yeah, can someone tell me or collect the data and tell me? I will write everything. So firstly, accumulate all the data which is given to you in the question.
Flow rate Q is given as 5000 liter per day.
Yeah, so flow rate of the slurry which is given as 5,000 liters per day, right? So let's, yeah, so next,
Input is 20% of, mm,
solid, yeah. So
yeah,
this is the slurry which is fed to a biogas plant. So you can say this is the biogas plant. Okay, so it's always helpful to draw a schematic and write down all the values, right? So let's do that. So here the flow rate is 5,000 liter per day, which is having 20% solid. So 20% if you say weight by volume, so solid content is 20%. So you can say 1 liter of slurry will have 20% solids. Now here the basis at which, like, it can be percent weight also, it can be percent um, volume also. So firstly, let's take two cases. You can assume anything in the exam, but I am just giving you the hint how to do if some sort of basis is given. So if it is percentage weight by volume, then what you can say, 20%, 20 percent weight will be in uh, total 100% volume, right? So you can say that if it has 1 liter of, and since the density is 1 kg per liter, so if it is 1 liter of slurry, then it will have 1 kg, sorry, sorry, I'm just missing some.
5000 kg.
Yeah, so this density means 1 kg is present in 1 liter of, uh, like 1 liter of slurry weighs 1 kg. Okay, so if you convert this, then 5,000 liter of slurry will have 5,000 kg of slurry, right? And out of that, you can say 20% is solid. Yeah, so it is a rate, so 5,000 kg per day. So now this will turn out to be, what will be the amount of kg that is there in 5,000 kg per day slurry? So that is 20% of 5,000. Calculate this.
1000.
Yeah, so 1,000 kg per day is the rate at which solid enters, or the amount of actual solid which is present in this slurry. So you can write this down, 1,000 day, sorry, kg per day. Solid is entering into the biogas plant. Now here you are given some composition of this food grains, which contains carbon, hydrogen, oxygen, and nitrogen, and percentage weight, like the weight percent are given. So you can say that 50% of this 1,000 is carbon. So 50% of 1,000, which is 500 kg, is carbon. Then you can say hydrogen is 100 kg, oxygen is 30%, which means it is 300, and nitrogen is 110. Yeah. So um, now if you look into the question further, then you can say it is given that 80% of the food grains is converted to biogas, right? So 80% means out of 1,000, 800 kg converted to biogas, right? I hope everyone is following.
Yeah.
So, which means that 800 kg of biomass is converted. And here you are given that it is assumed that all the hydrogen that is converted to methane. Okay, so 80% of hydrogen which is converted, you can say that 80% of hydrogen conversion, which means 80 kg H2 is converted to methane, which is CH4, right? So what reaction that can occur in the biogas plant is C plus H2, it will give CH4, right? Now this, if you balance this reaction, then it is like this, or right? So all the hydrogen is converted. So you can say if you write down the molecular masses, then 4 gram of hydrogen consumption will yield me 16 grams of methane. Okay, so here everything is in kg, so we will keep it in that. Now here you can say 80 kg of hydrogen is converted, right? So 80 kg of hydrogen will yield how much methane? I hope you are clear or you are getting this conversion and the reaction. So whatever the methane which is produced is nothing but methane produced is just the cross multiplication, which is 80 into 16 by 4. So 320 kg biogas should be formed. Or sorry, methane should be formed. Are you getting what I'm saying?
Yeah.
So let me just give you the brief again. So first what we did, first we write down all the data, right? So from that what was obtained is uh, convert or calculate the solid content in slurry. Now from that uh, calculate each component, right? So percentage of each component is given. So calculate each component. After that, you are given that conversion is given on basis of hydrogen. So you note that down, write down the reaction and balance it. And for sorry, so last step would be for 80% conversion of for given 80% conversion of hydrogen, calculate methane production. This is just cross multiplication from the stoichiometric equation. Yeah, um, I hope it is clear.
Then I have a question. What
Yeah.
is the use of H is equals to 100 kg in this equation?
So yeah, H equals to 100 kg is the inlet that is given to you. Okay. So here, if you split this 1000 kg into the components, right? So it will have 500 kg of carbon, it will have 100 kgs of hydrogen, it will have 300 kg of oxygen, and 110 kg of nitrogen, right? So out of that
But
100,
total is not 1000. Total we are not getting 1000 again.
yeah, so there can be some stoichiometric error in the question. So you just follow the hydrogen basis here. So I was also uh, looking into that when I wrote down this, but it is coming to me 900, right? So this should also be 10. Then. Yeah. So here, for hydrogen basis, since it is given, so 80% of this 100 kg which is going into the biogas plant, it is converted into methane, right? So this is totally converted to methane. And what is the reaction for methane production? It is nothing but carbon plus hydrogen. It gives CH4, right? So this is
Okay.
how it goes. I hope you are like I am able to answer your question.
Yeah.
Yeah, so 100 kg which you are looking into, it is the inlet one, and the outlet will have 20 kg hydrogen because 80% is converted, which is converted to biogas, right? So 80 kg now it will go into biogas. So it is a sort of hydrogen production which involves reaction also. Yeah, so that's it from my side today. Um, if you have any other doubt, you can say, or yeah, someone raise the hand. Yes. If you don't have any doubt, then that's it from my side. We can end this meeting.
Yeah.
Thank
Thank
you
you.
for joining. Thank you, everyone.
Thank you, ma'am.
Thank you.